Dr. Joyce Malyn-Smith. And she really builds on our developing theme of collaborative communities and highlights the critical role of education efforts in preparing the nation's workforce for the AI applications of tomorrow. It's not just about research. We've got to educate people how to use that research, benefit from it, contribute to it. Dr. Joyce Malyn-Smith is a distinguished scholar at the Education Development Center, or EDC, whose global team supports the delivery of education and workforce development programs spanning early childhood to adulthood. Having worked for EDC for some time, Dr. Malyn-Smith's research investigates the foundational skills and approaches to human technology partnerships that K through 20 students need for emerging occupations that involve computational thinking, big data, artificial intelligence, and other advanced technologies. She uses these insights and a knack for instigating collaboration to support cross-institutional teams of educators in the development of educational standards, tools, and resources that ensure a future-ready workforce. Funded by the NSF's NARE-associated Educate AI program, Dr. Malyn-Smith is the principal investigator on a project supporting a group of community colleges across the country to develop robust data science programs that meet the growing demand for AI-ready data technicians with just 2 years of post-secondary curriculum. While she assures me that the project is really just a continuation of EDC's support for collaboration among these community colleges and industry partners, I think it's an excellent example of the trailblazing agility with which the nation's smaller and more community-centric colleges are designing novel data science and AI education programs that the rest of us can learn a lot from. She's a powerhouse of expertise that might inform your ideas for broadening education participation in the NARE pilot this afternoon. Please welcome to the stage, Dr. Joyce Malyn-Smith.
Thank you, everyone. And I look forward to having the opportunity to share some of the things we've learned over the past many decades of our journey into thinking about how do you develop the workforce of the future, and particularly around the project we're engaged in now around AI. So I want to say that I lead a body of work at EDC on how people develop skills and knowledge in and out of school, and then translate that into productive and rewarding work. This morning, I'll be going over some things which I hope you'll find thought-provoking, including what we've learned about integrating AI into community college programs, some overarching frameworks and principles that are guiding our work, project goals and partners, what we've learned about AI that's bound to help us determine what we're going to include in the curriculum and the programs. But I'd like to start by telling you how I got here. And I began my career as a teacher and a central office administrator in Boston Public Schools during a very volatile time of forced busing and desegregation. And I met the most wonderful high school students who had 10 times more life experience than I had at the time as a new teacher. But they were trapped in a cycle of poverty that had no way out, absolutely zero opportunity. And it made me begin to question what education was all about. And I began to ask, what is it that we need to provide to young people throughout their school experience, beginning at elementary school, middle school, high school, community college, graduate degrees? What do we need to provide to them that will make them advantaged in a world that's driven by technology? And that question has driven my body of work for the past 45 years. And has led us to the project we're involved in now about looking at AI career pathways. So how do we ensure that today's youth are prepared for these, to thrive in a world that's driven by technology? And we're focused on three things. The first is we have to anticipate and define the skills not needed just to get into work, but what's needed to succeed in future work, to be successful once you get there. It wasn't enough just to get a job. We wanted our young people to be able to be successful once they got into work. Then how do we translate these skills into education standards, programs, and curriculum? And then the third question is, how do we ensure that all of our children, my children, your children, have an opportunity to experience these things so that they become advantaged when they leave school? So here are some of the things we learned along the way. One of the things is that there seemed to be a natural learning progression that young people would go through as they're beginning to become involved in technologies of all different kinds. The first thing they want to do is use it. Once they become experienced users, they want to dig into it, decode it, find out what's under the hood, what makes it work. Once they figure that out, they say, oh, well, how can I change this technology to do something I want it to do? And after they've mastered how to change technologies here and there, the next normal progression they move to is, how do I create new technologies to do something that hasn't been done yet? And if you examine how young people engage with technologies, you can see this pattern recurring. We also learned about career development, and career development is a continuum that begins with becoming aware of the world around you, aware of the opportunities you have, aware of the careers, the jobs, aware of yourself. What are the things you like? What are you interested in? What are you good at? What do I want to do in the future? And then that proceeds, after awareness, proceeds to exploration, to find out more detail about those things you find yourself interested in. And after the exploration phase, normally comes a preparation phase where you make some specific decisions about how to move forward in that career path. So what does this mean when we're thinking about an AI trajectory? Well, it means that students will use technology, building awareness of AI careers through AI literacy. And they'll learn to understand AI, exploring AI across careers through use cases or applications of what IA looks like in different career sectors. And then they'll begin to modify and create IA technology through specific career preparation programs like software engineering or other ways where they become the tool makers and the designers. So here is what career development for AI might look like. Career development is an iterative process with skill development informing personal and career development of interests and values, and vice versa, along the whole career path. And I want to note two things about this picture. One that you may not consider is that whether we want to admit this or acknowledge it or not, career development begins early when we're at home, sometimes even before we go to school in elementary school levels, where we learn that mommy and daddy go away in the mornings. They go to this place called work. And look at all these people in my community that are doing different things. There are nurses, there are doctors, there are dentists, there are police officers, firefighters, librarians, crossing guards. All of these people do different kinds of things in the community. And then, so understanding that career development, our career development begins when we see those things influencing who we are and where we fit in the world around us. The next really important place or juncture around career development is middle school, because it's in middle school where young people are very naturally, psychologically and socially beginning to explore their own interests. They're beginning to determine, what do I value? What do I like to do? What is it in the world around? How am I going to fit in? And so middle school is also a place where young people are naturally going through these processes and where they're also making preliminary career decisions that are going to set them on a career path. They're going to choose what kind of high school to go to. Am I going to go to an academic school, a magnet school where I'll learn about music? Am I going to go to a technical and vocational school where I'll develop technical skills? So it's at the middle school level that's an important consideration along people's career path. And then as they move into high school, they begin a process of preparation by the courses that they choose, the electives that they choose, and the out-of-school activities that they become involved in. So that's what a workforce or career education model looks like for people. So why community colleges? One of the reasons is that the community colleges are now considered to be the workforce engine of the United States economy. And I remember hearing from a program officer a number of years ago, and I'm not sure if these statistics still stand, but he said, hey, Joyce, did you know that for every scientist and engineer, there are 7 technicians supporting their work? And most of those technicians come from community colleges. So other reasons why community colleges are important to consider is that they're affordable. In some states, community colleges are free of charge. It fits into the lifestyle of working adults. As you can see, many of the community college students are employed, either full-time or part-time. They offer stackable credentials so that there are a lot of options for students. After a community college program, they can go directly to the workplace, or they can go on to a 4-year degree program. So in this particular project, integrating AI into community college programs, we have a group of partners, 5 community colleges that have been working with us for a number of years. And one of the reasons why this particular program worked well is because they were ready to take the next step forward. We had already worked with them on how to develop data science programs at their community college level. And all of them had developed programs, degree programs and certificate programs in computer science, and had followed the same pattern of program development, had been interested and experienced in working together. They were a really good, close-knit team. And for those of you who may know, I want you to say that Bridgerland is in case these are in your neighborhoods, Bridgerland is in Utah, Bunker Hill in Massachusetts, Green River in Washington, Hartford in Maryland, and Nashville State in Tennessee. So what are our goals and objectives for this program? The first goal is that we wanted students to be able to transition from 2-year programs into baccalaureate programs in computer science and AI. So that's one of our goals to work towards. And all of the 5 community colleges have agreed to these goals. The second goal is that the colleges would operationalize strategic plans on how to get there. So strategic plans on what are they going to do about AI in their colleges to be able to get to that point. And the third goal is that they needed their faculty then to be well prepared to be able to teach these new courses or modules that we would be developing. And the last that we thought was really important was that not only those colleges, but other colleges would have access to the materials and the services that they developed so they could share their story with others. This is the process that we adapted based on the work that we'd done before with these colleges around developing programs for data science. The first step is to organize a team for them to inventory their assets, to conduct a local labor market assessment. The second step, and I think the most important when you're developing programs and curriculum, if you want those programs and curriculum to be effective, is to do what we call about identifying a common language. And I'll be talking more about this a little bit later. But we will be developing a profile of the AI-enabled data practitioner, that middle-skilled worker who's working on AI teams. We'll identify and address the gaps between local industry needs for that worker and what their skills are and what's offered in the colleges. They'll develop employer engagement plans. Then they'll integrate or establish new courses around AI. We're planning to do 3 things. The first is to develop an AI literacy set of modules that can be integrated into existing courses or that can be bundled as a course, an independent course of its own and offered at the university, at the college. And then the second is to develop a set of examples of what AI looks like across different career sectors so that people can become interested and motivated and learn about, not only deepen their learning about their own area of interest and focus, but also learn about AI. And the third thing will then be to work with their data science programs to deepen those experiences. We'll have them work on a curriculum analysis to figure out what they're already teaching, what needs to be added, develop a stackable credentials model, and if we have time, we'll develop some performance-based rubrics. Then they're developing, some of these things are happening sort of in concert with each other. They're in the process now of developing a strategic plan for AI literacy and AI data analytics, and I'll report right at the end of where they are in that process. We'll be developing, and sorry, that happens all the time. I don't worry about it anymore. They'll be developing and piloting a curriculum, and the important piece here is that we'll be co-designing the curriculum with them. It's not that EDC is leading this effort, so we're the curriculum designers. We're putting together teams of faculty from the 5 colleges to help us determine what should be the major topics, what the modules should look like, and then once they've provided that input, we'll draft those up, give it back to them for review and critique and amending. And then the last piece is to develop specific pathways to 4-year degree programs. That'll happen in 2 ways. One way is that they'll develop articulation agreements with universities that they partner with in their local communities. And the second way is that they may develop 4-year certificates within their own institutions. Some of them are doing that as well. So here are some things that are influencing, we anticipate will be influencing the curriculum that we're involved in developing. One is MIT's Developing AI Literacy Curriculum, or DAILY for short. This is a curriculum that was originally designed for middle and high school students, and it was designed to be integrated into core subject matters such as math, science, social studies. One of the things we'll do, of course, is to learn from this what worked and what didn't work, and then adapt it for the community college population. The second thing we'll do is learning from some past experiences in integrating information technology across careers. We're going to develop use cases or AI applications across careers. And it's interesting, I went through some of our old materials, and this is a scenario that was actually lifted entirely from the AI integration. I think the AI purpose at that time was learning to use the internet. And I just added the words IT applications and using the internet. And I just added the words AI just to see how it would fit. And as an example of the kind of use cases we're looking to develop. We'd like to develop about 10 of these that will show students and faculty how AI is used in different career sectors. And I want to say that these are not developed by educators, these are developed by frontline workers. As you can tell through some of the detail in this one, you really need to be involved in doing the work to be able to have the detail come through the scenario that will help you learn more about the work that the particular area that you want to explore. The third thing we're going to be, that's going to be informing our work are a set of units that were developed through a program called Science Plus C, and we'll do this to deepen and extend AI learning within data science courses. These units were already introduced in our community of practice to our colleges, and they've all looked at them with great interest and would like to adapt them for their data science courses. And again, we're going to be co-designing an adaptation of these units at the community colleges when we work together. So, and really important, to determine what's to be taught, one of our grounding principles is we need to go directly to expert frontline workers to understand what the work really looks like. And the backbone of any new career pathway is a profile. EDC has been involved with developing profiles for new and emerging occupations for the past 30 years. And it's really a unique approach because we've worked out a process to be able to capture, to be able to define a job that has never been defined and in detail, and then to be able to analyze that job with sufficient detail to be able to develop programs, curricula, assessments, certifications, and things like that. So I'm going to walk you through a process that we use because one of them might be, you might find of interest. All of the colleges who we're working with have implemented those new programs for data science based on this profile of the data practitioner, which describes what the skills and knowledge and the work tasks of that middle skilled data worker. We developed this profile with expert data practitioners maybe 8 years ago, 9, 10 years ago. It does need updating, and one of the things we will be doing in this project is updating this. But we developed this before there were any programs at the community college level developing data analytics skills for workers there. So I want to again emphasize that this is really the backbone of any of the pathways we've developed to new and emerging occupations. One example of the impact of this, and I'll just say this very quickly, back in 2010, I think you probably all remember when everyone was talking about this new thing called computational thinking. Do you remember that? Way early, and maybe it was 2006, it was a while ago. So of course, following this process, we wanted to know what are scientists, if you're computational thinking enabled, what are you doing at the work job? What's your work like? So we put together a panel and we developed a profile like this of the computational thinking enabled research scientist and one for the computational thinking enabled product engineer. And what we found on that profile was that at least half of the duties and tasks had to do with modeling, using using computer models to be able to do their analysis. And as we thought about that, we looked back on the education system and realized that young people were not learning any of those skills in K-12 education at all. My two sons went to a school in Boston. I don't know if you're familiar with Boston schools. There's a school in Boston called Boston Latin School. It's supposed to be one of the best schools in the state, one of the best schools in the country. Very classical. They were learning Latin. They were learning Greek. They were learning music. They were learning art. What they were not learning is anything about computer science. They had one computer science course, which was their an AP computer science course at the time. No integration of computer science into any of the sciences. That had me worried. It had me worried because I asked the question, are my boys that I thought I was getting them into the best schools to get the best education, are they going to be the disadvantaged kids when they get out of school because they haven't had this background? So it made us start thinking about how to address this. And out of this came a project called Science Plus C, which we finished last year in partnership with the Massachusetts Department of Education, again based on what we learned from the profile. And now in the state of Massachusetts, there are 3 new courses that schools can elect to offer, and we're providing professional development for that. One of them is Biology Plus C computing, Chemistry Plus C, Physics Plus C. So a student can take, instead of taking the regular biology course, they can take Biology Plus C, and integrated into that course are units on how to do the science through computer modeling. And these courses have already been accepted by the Division of Higher Education for entry into post-secondary, for entry into college in our state. So I say that because I'll be coming up on something soon that warrants attention, and it all comes from this profile. And the profile comes from learning about the work through the eyes of expert workers. And this is what I want to share with you that you might find of interest. We recently did a project with Google because they wanted to know, what does the AI-enabled software engineer, and these were people who work in the division that develops the Google tools, and they wanted to know, what does the AI-enabled software engineer look like so that we can think about how we might want to upskill some of our engineers. So following the same process we had with many of the other profiles that we had developed, we pulled together our team of expert workers, and it took us, I'll tell you, it took us 3 months to find a handful, a small group, which was a required number for the process, of expert workers to contribute to be on a panel contributing to this work. They came from big companies, small companies, different types of companies, and they all didn't have the same job title, but they all did the same, they all were doing the same work in relation to AI. They were all AI-enabled software developers, and we set them through a very rigorous screening process, so we were sure that these were really indeed experts in doing that. So the first step they did when they came together was to develop an occupational definition that defined the work that they held in common as IT-enabled software engineers. And here's how they defined the work of the AI-enabled software engineer. They said the AI-enabled software engineer leverages, collaborates with, manages, and deploys AI technologies and systems to efficiently and effectively do the following: gather and generate information, plan and track work, develop, test, and commit high-quality code, experiment with approaches, release and monitor deployments, manage data, and generate assets. It took us a while to get here. We developed this at the beginning of the process, and then at the end, after we went through the entire rigorous process that took over 3 days of very intensive work, we went back and we adjusted it to make sure that it indeed captured what they believed at the end of the process was the work they all held in common as AI-enhanced software engineers. The next thing we did is we asked them to identify the big buckets of work that were associated with the occupation that we just defined. So again, throughout the 3 days, we had them focus on that occupation, which we kept up on the wall so they'd keep reminded of what it was and how they defined it. So here are the major buckets of work they said that they engaged in, as AI-enhanced software engineers. One of them was produce high-quality code, explore technical solutions, locate information, generate insights from data, generate holistic test coverage, investigate issues in production. I can't quite contextualize the work item, plus cross-cutting, that's the last. Ensure launch complies with legal, privacy, and security requirements, develop and document high-level technical designs, generate assets, improve reliability to avoid production problems, test the AI model, and produce up-to-date documentation. And then there was a cross-cutting skill about staying current with their tools and capabilities. Well, the process that we had followed in previous profiles all got us to this point, which was enough for previous profiles. But as we looked at this, actually there was one next step, and for the next step, for each one of these big buckets of work, they identified specific work tasks associated with that work. And in the parentheses, you can see how many tasks were associated with each of the big buckets of work. Well, up until this point, we found that this was sufficient to be able to define a new occupation. But when we looked at the AI-enhanced software engineer, we still didn't understand fully what that meant simply by getting to this level. So here's an example of one of the tasks. Under the duty of produce high-quality code, here are the tasks associated with that. Create a clear definition of the input-output formats. Generate proof of concept. Convert a loosely defined document into code. Convert thought process into code. Generate pseudocode. Minimize complexities by reusing and refactoring code. Produce extensible, readable code that is well commented. And proofread code and suggest improvements with an explanation. So again, we got down to the task level, and it still didn't tell us enough about what does it mean to be AI-enabled when you're doing these things? Because if we want to develop curriculum and programs, this wasn't at a sufficient level of detail. So what we ended up doing is we ended up asking them, and I'm giving you an example of one of the tasks, the task of convert a loosely defined document into code. We asked them to generate an example of what that looks like when they're doing that with AI. So the example that they developed for this particular one is I ask an LLM to convert a design document for a system into the different components that a developer would need to build the system. So we said, oh, well, that gives us a little more definition. We know a little bit more now about how AI is used in that specific type of work. But it still wasn't enough. We still weren't satisfied by, I don't have a picture. We didn't have a picture of what that means to be AI-enabled. So we asked them, tell us, when you're doing this, as the human and the partner in the process, what do you do? So they said, well, what we do is we might draw a rough sketch of the system. And they said, well, what does AI do then? Well, AI would then convert the sketch into code or a breakdown of different components needed for the project or problem statement. And then we said, well, then what? And the response was the human does something next, and that's to continue to iterate through AI outputs until the code until you get the desired result. Well, this really helped us understand better what the work of the AI-enabled software developer looks like when they're actually performing those tasks. Now this is at a level of detail that helps us as curriculum developers, as assessment developers, certifications and program developers, precisely what needs to be included in that curriculum. And I want to say one more thing. Those of you who've developed curriculum and assessments know the secret is in the verb. You need to look at the verb to figure out what to teach and what to assess. And we were very, very careful about being precise about the words that are contained in this profile. So once we had identified what the work looked like, of course we need to know more about what you need to know to do that work. So what we did is we had the panelists go through every single task and list the knowledge they needed to perform that task. And then as we reviewed the whole body of work that was produced, we found out that for all tasks, there seemed to be a general listing of knowledge that ran across all of the tasks. And this is a listing of what that knowledge seems to be for the job. Domain knowledge and application domain knowledge, knowledge about errors, knowledge about how and why AI hallucinates, knowledge of potential causes of errors made by AI, a pattern matching and data analysis, knowledge of the ground truth to verify accuracy, knowledge of system, product goals, corporate goals and trade-offs, knowledge of correct solutions and proper assumptions. Seem to run across all of, remember there are 81 tasks, or more than 80 tasks. This was a lot of work. I'm giving you one example of one task from the bucket of them all. It's a tremendous package of work that was accomplished by the team. The next thing we asked them is, okay, what tools do you use to perform that specific task? So for every task that's in the profile, the people on the panel listed the tools that they used to perform that specific task. And again, we're at the same example of a task, and here are the tools that they said they used. And of course, you know, tools change all the time. This was absolutely current when we did this about 4 months ago. I don't know if it's still current, but it needs to be updated, as you know, periodically. This is what I found really, really interesting and needs some explanation and some attention. When we asked them about skills for each one of the tasks, we went back and we analyzed all of these skills, and we found that there seems to be a generalizable prompting trajectory that they identified as a whole, looking across the whole job. And I learned from this because as I'm a novice in learning about AI, and I thought I was doing a really good job when I realized that what you really needed to know how to do was ask the right question. And I thought that's where it ended, but boy, did I learn a lot. Because here's what they said they do as they're prompting and using AI to answer some of these questions. The first thing they do is identify, given the context of the task, identify the information and the data sources that they need to provide to the AI. Then they need to prompt. They write a structured request that yields the specific information or product that they're seeking. And we got them to, again, we wanted very specific language that can be used by educators to generate learning products. So they needed to learn how to express their ideas in natural language, to communicate clearly the context, the problem statement, and the desired end result. They needed to then evaluate the response that AI provides, to integrate their knowledge together. And there's a whole list of things here: to recognize hallucinations, discern limitations of the tool, analyze the data and patterns, verify generated, this is a lot involved in this, you know, verify generated information, make a selection, a best choice given the human's domain knowledge, recognize incorrect solutions or faulty assumptions. And then they need to experiment, to test the solutions and options that are suggested. Then you iterate, refine the prompt, ask again with additional specification, requirement, detail, or context. And it talks a little bit more detail about that, to be able to then tweak or modify and adjust the AI-generated content. And then to finalize the product that you're developing, to create a final version and update the documentation. What really surprised me, and what we learn from working professionals, is that's not where it ends. Where it ends is when you socialize what you've created so that you help your team and others in your organization accept this solution that you've generated through AI. That just generating it is not enough. Other people need to be able to accept that solution. This was really helpful, and I think when we are doing our AI literacy curriculum and modules, we'll be referring heavily to this process because it provides more detail about prompt engineering that we've seen in other places. We also ask them to list the attributes that they need to be able to do this work. And here's a list of the attributes that they called out, again, that we analyzed for all tasks across the profile. Analytical, articulate, collaborative, skeptical, interesting, vigilant, user and customer first thinking, patient, perseverant, inquisitive, leadership, logical, detail-oriented. So all of these things provide input into the process and the core content that we'll be developing in our program to integrate AI into community college programs and courses. Again, you can see that, I don't want to go back over this process, but I do want to let you know that over the past number of years, we've had opportunities to implement this process a number of times and have created a number of useful tools to help educators do this work. For example, we've developed a building blocks template to help them organize and inventory their assets. We've developed the profiling process that I just described to you, and I gave you a couple of examples of that. We've developed a curriculum analysis matrix, a way to look at your curriculum and against these specific skills and see the degree to which you're engaging students with those particular skills. We've developed a gap analysis tool, which most people have found really, really interesting because it provides actually a quantifiable number that will tell you how close or how distant your curriculum is from the expectations of your local businesses for any specific work task or skill. So we've developed a number of very useful tools for this. Where we are now, our colleges are in the process of developing strategic plans. We have two colleges have no strategic plans at all. Two are developing their AI plans. The ones that have no plans are starting them, I want to say. Two are in the process of developing their AI plans. One has a plan in place. Partners have a range of programs and courses and certificates already in place or planned, and you can see those on the right. Our plans are in about May, we want to conduct a panel that will define the work of the middle-skilled AI data practitioner. I don't know yet what that will look like as a final product. We'll certainly use as input the work that we did with Google on the AI enhanced software engineer, but I don't know. We'll be working to co-design that whole process again with our colleges and with their business partners. In spring and summer, we'll co-design the AI literacy modules and the problem scenarios, and in the fall, we'll pilot those, and then in the next fall, we'll begin to work with the data science colleges. So I just want to go back and take a look at again what we had a chance to review this morning. We've reviewed what we've learned about a trajectory of learning around technology and around career development. We've talked about those overarching frameworks and principles that have been guiding our work. We talked about our project focus and goals for the project that's funded, about integrating AI into community college programs. We talked about what's informing our work, and those things are listed out there, and the pathway development process and planned activities. So thank you. For more information on our work in general, check out EDC, and I'm happy to share this with you. You are all so quiet. You know, when you're a teacher, it makes you wonder what everyone's so quiet out there. But if you have any questions, I'd be happy to answer some questions.
Questions?
Should I go? Thank you for the talk. And having been involved in our local school district in New York State, I sort of know where the high school students are. And most of them don't want to get into math or science or anything. They want to do something else.
Because their interest begins earlier than that.
Indeed,
you know?
right? So, and then how to motivate them is one thing. And,
yeah.
And so I have a comment and a question. Given typically when you have a major changes in technology, you have like maybe 2 decades or something to make sure that the workforce is trained for that technology. It goes back to the internet, goes back to all kinds of other technology over the years. In this case, you're not going to have that much time to actually get the population ready for this, which is a very unusual challenge, right? So that's how do you deal with that, given the pace of normal evolution in high schools and colleges? How do you deal with the rapidity in which you need to do these things? In the case of AI is the first question I have for you. But at the same time, I think you're giving too much credit to AI in the use cases you just went through. Because one of the things we know is you need to be able to assess the output of something is good or not. That needs experience.
Correct. And I hope that was listed there somewhere.
So it's like a joke, right? You get 5 years experience. You don't start with 5 years of experience to begin with, right? So the question becomes, how do you get the experience So my suggestion overall on this topic of how much the machines do and how much the users do, you should define the tasks humans should do to begin with for anything you're doing, and then figure out which of the tasks can be done by a machine, maybe a better way to go, compared to assuming the AI is going to do all kinds of great things and you're going to figure out how to use it, right? Because that puts you in a very bad spot if the AI misbehaves.
Thank you.
Thank you.
So a couple of days ago, I was part of a discussion at Clemson's Media Forensics Hub where the topic was researchers wanted to design a survey to measure AI literacy. Mm-hmm. And at the beginning of that discussion, we said, okay, let's operationalize. What do we mean when we say AI literacy?
It's a good question.
Yeah. After an hour and a half, we gave up and despaired and all went home. So my question is, how do you, what's
How will
the
we get
difference
there?
between a student who is AI literate and is not?
Well, I think that what we're doing is we're looking at models that maybe a lot of people may not know about them or think that they're developed for another purpose or another population. For example, the MIT middle school curriculum on AI literacy identifies some really interesting topics that might be important for everyone. So those are the kinds of things we're looking at to be able to figure, after we look across all of those different kinds of resources, the colleges and their business partners will look at them and they'll nothing's perfect, but they'll figure out what seems to work for them. We're just at the beginning of the process. I'm excited about that the process is moving forward and that we'll get a product. Not everyone will agree with what it is, but it'll be a product and it'll be tested and it'll be used and we'll try it out. Maybe next year, if we have another meeting, I can report back and let you know what's happened.
So I had a question. At the beginning, you had a slide that showed that there's 1,000 colleges that teach 10 million students. You're working with 5 colleges right now.
Oh, no, right.
How do you imagine it scaling out from 5 colleges to 1,000 colleges and 10 million students?
Well, it's a hard question. It's not a hard question to answer. It's a hard question to operationalize. We began with 4 colleges that were developing AI programs. Those became mentors for other colleges. So the program grew to be about 8 or 9 community colleges that were working on data science. We now have 5 colleges that really want to get into AI. I would hope that as we're engaged in this process, we'll have an opportunity to mentor other colleges who are engaged in AI. We'll take the products and resources that we develop and make them broadly available to people across the country so that they can use and try out the materials. And everyone is jumping on AI so quickly that we're hoping that with appropriate resources and support, we may get there sooner than we might have with other technologies. There's no magic solution. But if you find one, please let me know what it is.
Thank you. So in regards to the AI-enhanced software engineer curriculum, do you think there's some danger in having this associate's degree specific with AI, specifically how do you expect a student to be able to judge the quality of the AI's code if they don't already have an education?
So the example I gave you of the work we did with Google is an example of very high-level experts who are AI-enabled software developers. We don't expect community college students to be doing that work. But we found when we've done these kinds of profiles that there is some overlap. There are some skills, there are some activities that are done by high-level professionals that are also done by technician-level people. So we'll be looking at that work to not only see what the structure and format of the work is so that'll inform how we organize the curriculum that we're doing, the AI literacy curriculum and the curriculum that will provide foundational skills to the data analytics program students. And also what skills, how do we look at the skills trajectory to be able to develop an articulation agreement with a 4-year institution who may take the middle skills and build on those as students transfer into baccalaureate programs. So I wouldn't expect students to be able to do the work of the AI-enabled software engineer. But there's a lot we can learn from the work that we did there.
Hi, good morning.
Good morning.
I'll just take this off. Good morning. My name is Jory Dale. I'm from Prairie View University. I have 2 questions. My first question would be, so with the integration into the classroom, I saw that you said that y'all have been using existing coursework. How does that look if it's not always a STEM coursework? How are y'all laying that foundational knowledge of AI and then also asking them to do that literacy work of understanding what is being put out by the AI?
I can tell you next year.
Okay.
Because that's one of our first questions. Once we get our colleges together and we identify together what do we mean by AI literacy for the community college student, then the question is how do they integrate it and where do they integrate it? We're planning to develop modules that then they can integrate into their coursework. Every one of the 5 community colleges is different. Some of them may want to do a standalone course. Some of them may want to integrate into this area. Some of them may want to integrate into another area that they focus on. We're hoping to be able to create products that have the flexibility to be able to do that.
Yes, ma'am. And my follow-up question would be, I'm working with the provost for an undergraduate task force, and we're trying to revamp some of our courses. But with embedding that technology and the integration of AI into the system, how are you looking at ethics? Do you already have a policy and procedures on how to conduct not only with academic integrity, but the use of AI in the classroom for the students?
So we have our own IRBs that we have to follow
Yes.
within our own institution that are very carefully monitored. And a lot of those questions about ethics, we'll be discussing that within the 5 colleges because they all have their own, some of them have policies around AI, some of them don't have policies yet, or will be having, but this may provide input into what some of those policies become. We don't have, we will be addressing it, but we don't have, again, we just started this project. I think we're only about, 6 months into the project itself. So we have a head start because the colleges have all worked together before and they were ready to begin. And we all know what we want to do and we've made a commitment to do the work together. But we don't have a lot of the answers yet, but we have the questions.
Yes, ma'am. And just to follow up, because that was such a great answer. I'm also working with our AI committee with the CIO. So with that, once you all have policies and y'all figure out how you would like to regulate the students, will that be blanket for the whole program? Or do you think that it would need to be niched? Yes, because the colleges are different, but the program has the same curriculum.
What we hope to do is to create some core materials and policies and procedures that all of the colleges can use and rely on, but understanding that colleges are different and they may have different implementation models and contexts. We do expect them to adapt as long as there's a core set, as long as there are core concepts and core curriculum, then they're adapting that is good. We do expect there'll be some differences. We don't know what those differences will be yet, but differences would be good.
Thank you.
All right, so this will be our last one.
Hi.
Hi.
So there was a really interesting panel at Supercomputing this past year about using large language models to write papers. So I was wondering, from your perspective as an educator, how do you feel about students using these large language models to write their papers, in some cases, completely for them? Or where do you think the line is on using AI and then using AI to just do all of your work for you?
I'm still sort of trying to figure that out on my own as well. I'm concerned that young people will lose the ability or never gain the ability to be able to think and to think critically and to be able to generate their own ideas, to be able to analyze and synthesize. I don't think I'm in favor of turning all of that over to AI because we'll be losing too much as a society. And I think that the foundations of things like that need to be learned early on. When students are first being exposed to AI in elementary school and middle school where they might be using it to write it, that's where you have to instill those kinds of values. Yeah.
Thank you.
You're welcome.
Let me just say one thing. In case you're not aware, the AAAI actually worked with teachers' organizations across the country. There is something called AI for K12.org. They actually have schooled by grade, what can you teach and how they're going to play with things and whatever.
Yeah.
So there is quite a bit of literature and work there, if you can do it.
Thank you very much. And I just want to mention the person that we rely on a great deal for our advice on AI education is a researcher by the name of Irene Lee. I don't know if any of you are familiar with her work. She does really wonderful work around computational thinking and computer science and AI. She is a computer scientist herself and has dug deeply into AI, so we'll be relying a lot on her guidance. I'm not an AI specialist, so I'm not the person to answer a lot of technical questions, but we have great people who are helping us figure that out.
Thank you so much.
Thank you.
Thank Dr. Malyn-Smith.